Hey everyone. So today we're diving into a scientific detective story that's been hiding in plain sight for over 70 years. It's a mystery that's been buried in old photographic plates of the night sky, and it looks like a series of really clever tests may have finally cracked the case.
I mean, just think about this for a second. It sounds like something straight out of science fiction, right? You look up one night, see a star, and the next night, poof, it's just gone. But what if this was actually happening? Well, that's the exact question a project called VASCO, that's short for Vanishing and Appearing Sources During a Century of Observations, set out to answer.
And what they found is, well, it's pretty staggering. By meticulously scanning these old photographic plates from the 1950s, astronomers found and cataloged over 100,000 of these transients. These are basically just dots of light that show up on one single photo and then are never, ever seen in that same spot again.
Okay, so the heart of this whole investigation really goes back to the first Palomar Observatory Sky Survey. And you gotta remember, we're not talking about digital images here. These are actual photographs on glass plates taken of the night sky between 1949 and 1957. And hidden inside them is a really, really strange clue.
And here it is. This is the first major clue that something physical, something real is going on. Researchers found that these vanishing objects appeared less often during geomagnetic storms. You know, that's when the Earth's magnetic field is getting hammered by solar activity. And this wasn't just a hunch. The correlation is incredibly strong, with a statistical certainty of 3.4 sigma. To give you some context, anything over 3 sigma in science is considered really strong evidence.
But hold on a second. Whenever you find something truly weird, the first thing a good scientist does is try to prove themselves wrong. Could this just be a mistake? You know, a glitch in the 70-year-old equipment? This leads us to a very plausible and honestly a much less exotic explanation.
And that explanation is called the airglow artifact hypothesis. The idea is actually pretty simple. When there's a geomagnetic storm, it can make the Earth's upper atmosphere glow ever so faintly. This airglow acts like a kind of natural light pollution, basically fogging up the photographic plate and making it harder to see faint stuff. So, maybe the transients aren't actually vanishing. Maybe the camera is just being temporarily blinded.
So, this is the crucial point, right? Are we looking at a brand new, unexplained physical phenomenon where these objects are actually affected by Earth's magnetic field? Or is this whole thing just a measurement error, a ghost in the old machine? That is the question we absolutely have to answer.
To get that answer, researchers designed a brilliant test using the exact same data from the Palomar Observatory where this whole thing started. And the logic behind it is beautifully simple and clear.
Okay, so let's just think this through. If that airglow idea is right, and the storms are just making the photographic plates less sensitive, then what should happen? Well, the effect shouldn't be picky. It wouldn't just affect these weird one-off transients. It should affect everything faint.
So, the test itself was really elegant. The scientists decided to use regular stars as a control group. They went back to the very same photographic plates and just counted the number of faint stars they could see. If the glitch theory is correct, if the plates are just getting fogged up, then the number of stars they could see should also drop during those storms. Makes sense, right? So, let's look at what they found. First, they totally confirmed the original finding for the transients. Yep, they are strongly suppressed during storms, with that same high statistical significance of 3.4 sigma. No surprise there. But what about the stars?
And this is the bombshell. The number of stars they detected showed no effect at all. The statistical significance is just 0.4 sigma, which is basically random noise. The storms that seem to make the transients vanish have absolutely zero impact on the number of regular stars seen on the exact same plates.
So when you compare the two, they're separated by a massive 3.0 sigma difference. This is a huge, huge problem for that simple glitch theory. Whatever's happening here, it's specific to the transients. It is not a simple camera problem.
But you know how science works. One test is never enough. To be absolutely sure, you need independent replication. So the investigation moved to a completely different set of data from a different place, the Harvard College Observatory Plate Collection.
And this step is so incredibly powerful because it's not just about rerunning the same test. They used a different observatory with different telescopes and cameras, different types of photographic film, even a different way of digitizing the plates. The idea is, if the result holds up under these completely different conditions, then it can't possibly be some simple equipment quirk at Palomar. And the results were just crystal clear. At Palomar, the star counts showed no trend. At Harvard, they used a different metric called limiting magnitude, which is just a fancy way of measuring the faintest object a plate could capture, and again, no significant trend. So you've got two different observatories, two different methods, but one identical conclusion. Geomagnetic storms were not affecting the overall sensitivity of the photographic plates.
So, where does that leave our detective story? Well, with the main, most plausible objection shot down not once but twice, it's time to deliver a verdict.
That simple, boring explanation, the glitch theory, is officially ruled out. It's been falsified by the data. And what that means is that the suppression effect, it's not an error. It's a real, physical phenomenon that is happening specifically to these transient objects. Now, this study wasn't done in a vacuum. It was actually the crucial final piece of a much larger puzzle. You see, there were already 4 other independent lines of evidence suggesting these transients were real and connected to earthly events. This study served as the essential artifact control, the final check to prove that all those other results weren't just some big camera glitch. And when you combine all 5 lines of evidence together using standard statistical methods, the result is 5.5 sigma. To put that in perspective, in particle physics, 5 sigma is the gold standard. It's the official threshold for claiming a discovery, like when they found the Higgs boson. This is an incredibly strong signal. So we're left with this really powerful conclusion from the paper's author. After all the tests, all the replications, the evidence is pretty much undeniable. These 100,000 points of light, they are not mistakes. They are real. They are somehow physically linked to our planet's magnetic field, and they behave in a way that nothing else in the sky does. Now, the mystery of what they are, well, that remains completely unsolved. But the mystery of if they are is now closed. And that, in itself, just opens up a whole universe of new questions.